Okay, in 9.1, first thing we're going to talk about is the distance formula. So in the distance formula, we have a situation where there are generally 2 points that we want to find the length in between. So sometimes they use the word distance, sometimes they use the word length. And what we're going to do is we're going to start out by looking at the length between these 2 points. And if I want to find that, I go to my coordinate axes and I plot the points -1, -2. So -1, -2 would be right here. And 3, 6 would be right about here. And in the past, if we're trying to find the length between these 2 points, one of the ways that we could do that is we could look at the 2 legs and go from there. So we have one leg that's horizontal, looks like this. One leg that's vertical, looks like this. And we could talk about the lengths of those 2 legs. So for example, the vertical leg, we could figure out would be 8 by counting the squares. And the horizontal leg, we could figure out would be 4. And then we used to have a technique in the past called the Pythagorean theorem. So using the Pythagorean theorem, we know that a squared plus b squared equals c squared. Or in other words, one of the legs squared plus the other leg squared equals the hypotenuse squared. If I were doing that in this particular triangle, I would say 4 squared plus 8 squared equals whatever the hypotenuse squared, which in this case I guess we were calling c squared. Then as we simplify, we get 16 plus 64 equals that c squared. Or in other words, the c squared is equal to the sum of those 2 things, which would be 80. And then in order to find that, you could take your calculator and take the square root of 80, and so if somebody could do that for me. 8.494?
Or 94.
8.94, thank you. 8.94. And so this would be the length of that hypotenuse. Now there's another way to do this. It's called the distance formula. And the interesting thing is the distance formula is really just another way to talk about the Pythagorean theorem. And I'll show you what that is. So in the distance formula, we have that our distance is equal to the square root of, and you might recognize this formula, x2 minus x1 squared plus y2 minus y1 squared, and take the square root of all that. Now these 2's and these 1's are really talking about the points that they come from. So if we look way back up at the top, what you'll see, and I'm now going to erase that information. If you look at the first point, and we call that the first point, then that's referring to the x1 here and the y1 here. So the -1 is the x1, and the -2 is the y1. And if we look at the second point, 3, 6, the 3 is the x2, and the 6 is the y2. And so all these little subscripts, the numbers 1's and 2's on the bottoms of the x's and the y's, they're just telling you which point they came from. That's it. We can also talk about the middle of that red line there if we want to, that segment, by using the midpoint formula. The midpoint formula is okay, well, I wish I could spell, sorry. The midpoint point is equal to x1 plus x2, meaning you're adding up the two x values from the points, and taking their average, which means dividing by 2. That's the middle. And then you're doing the same for the y. So you add up the two y values, chop that in half, and that's the average of the two y values, and that's the middle of that segment. So if I look at the first example, and I try to use the distance formula, and we go back to what we were talking about earlier from the color coding, this would be my x1, y1, and this would be my x2, y2. And specifically, if I was labeling them, this would be x1 for the 9, this would be y1 for the 4, this would be x2 for the 8, and y2 for the 6. So now if I tried to find the distance using our formula, I would go, my distance is equal to the square root of, and I would take the x2, which is 8, minus the x1, which is 9, and I'd square it. And then I would take the y2, which is 6, minus the y1, which is 4, and square it, and then square root the whole thing. And I can just type that into my calculator. And if you were to do this by hand, you find out this is roughly, or this is, I should say, excuse me, the square root of 5, which is roughly equal to 2.24. So give that a shot on your calculator, see if you can find the same value. Make sure you have parentheses in the correct spots. That's very important. And see if you can get that. Okay, number 2, let's say I'm looking at jk to see what that value is. So from j to k, if I pick my j to be the 1 stuff and my k to be the 2 stuff, then the distance will be the square root of, and I'll have the x2, which would have been negative 1, minus the x1, which would have been 3, squared, plus the y2, which is 2, minus the y1, which is negative 5, squared. Don't forget to square root all of that. If I were to simplify the first parentheses, negative 1 minus 3 is positive 4, or sorry, is negative 4, but negative 4 squared is positive 16. And 2 minus negative 5 is actually 7, and 7 squared is 49. And I want the square root of all of that, which is the same as the square root of 65. So if I'm looking at what's going on inside, this stuff turned out to be 16, and this stuff turned out to be 49. If I do the same thing for the lower pair from k to l, they're talking about these two together. This time k is my x1, y1, and l is my x2, y2. So if I do that distance, I would have the square root of, and this time I would have negative 5 minus negative 1 squared, plus negative 5 minus 2 squared. And I'm taking the square root of all that. In the very first parentheses, negative 5 minus negative 1 is negative 4. If I square negative 4, I get positive 16. In the second parentheses, negative 5 minus 2 is negative 7. But negative 7 squared is positive 49. And what I notice is these both turn out to be the square root of 65, so the answer to this question is yes, they are the same length. So looking inside, this information was 16, and this information was 49. Number 3 doesn't really give me a lot of room, so what I'm going to do is I'm going to open up a new page here. I'll do number 3 on that page. So in number 3, it says find the distance, or it tells us the distance between 2, 3 and x, is that negative 5?
Yeah.
Negative 5, thank you, is 10. And they want us to find x. And so in the setup of this problem, you use the distance formula, and that is that I know that x minus 2 squared plus negative 5 minus 3 squared square root is the same as 10. So the left side is talking about the distance between those 2 points, which we use the formula to write down. And they tell us the distance is 10, and in math the word is means equals. And now I have to solve this equation. So this equation involves algebra. And the first thing I notice in this equation is that I don't really like that they have a square root there, because that's kind of messing me up. So what I'm going to do is I'm going to get rid of the square root. In order to do that, I'm going to square both sides. So I square this side, and I square this side. If I do that, then the left-hand side, the square root and the square undo each other because they're inverses. So I end up with x minus 2 squared plus, if I simplify that other parentheses, negative 5 minus 3 is negative 8, and negative 8 squared is positive 64, and that's equal to 100. I then would subtract 64 from both sides. If I subtract 64 from both sides, I end up with x minus 2 squared equals 36. And now what I notice is the thing that's kind of messing me up a little bit is the square on the parentheses. So I want to get rid of that. So I square root both sides. And when I square root the left, just like in the light blue, the square root and the square undo each other because they're inverses. I get x minus 2. And on the right-hand side, I get the square root of 36, which is 6. However, because in the left-hand side in pink, I square rooted something that contained a variable, the right-hand side needs to have something special. It needs to have a plus or minus next to it. Because if you think about 7 squared, that's 49, and negative 7 squared, that's 49, there are 2 possibilities. The 7 or the negative 7 could have been the thing being squared. So when you square root a variable, you have to take into account both possibilities. That's why there's the plus or the minus there. And then the only thing left you have to do, of course, is then to move the 2 over to the other side. When you move the 2 over to the other side, you end up with x equals, and then the 2 becomes positive instead of minus, and it's plus or minus 6. And what this is saying to us is that our 2 possibilities are 2 plus 6, which is 8, or 2 minus 6, which is negative 4. And so there are 2 possibilities that you should check to make sure that they both work, but 8 and negative 4 should both be solutions to what the x could be in the original red set of ordered pairs. Okay, number 4, it's a word problem, and probably the biggest difficulty with